Good morning, students. So today I'll explain the first program that is in your textbook. Okay, it's on page number 1.182, Inheritance Extending Classes. So if you have watched the previous two presentation slides, okay, videos, uh, I'm sure that you have understood the definition of inheritance, and then the difference between base class and derived class, and the visibility mode or access specifiers, that is private, uh, public, protected, and so. Okay, so you have to understand the visibility modes very nicely. Okay, and what is base class and derived class. Okay, based on that, the whole uh, topic of inheritance, it covers up like that. Okay, so now here you have a program. Okay, you have a program here. So demonstrate a sample example on class inheritance with a factorial program. So we have already seen factorial program uh, in class 11, right? So many times we have seen this factorial program. So I'm sure that you know the concept of factorial well now. And so this is the program logic of the factorial. Okay, so here in this program you'll see that two classes are defined here. So that is the concept of inheritance, right? So this is a normal class declaration. Okay, so the class is defined here, and here another class defined here. Okay, so now, so if you see this inheritance program, okay, do not think that it is as a strange program. Okay, it's just like a normal class program only, except that you have multiple classes in the program. Okay, so in this particular program you have two classes. So here the class this is the class base. Okay, the class definition ends with the semicolon here, and just below that another class. Okay, and the class definition ends here. Okay, and then you have your normal member function definition. Okay, function definition, you have your main function. Okay, so nothing much strange, only thing that you have two classes repeated. Okay, same like when you use function overloading, constructor overloading, like that, right? Polymorphism concept, you use the same function name twice, thrice, like that, right? So here you are using the two class, but the class names will be different. Okay, the class names will be different. And why is it necessary to use two class here? Okay, it's because like you do not randomly write declare another class in the same program. There has to be a link, okay, a relationship between the first class and the second class. Okay, so that is the whole concept of inheritance. Okay, a relationship between two classes or two or more classes, then only you can write down the class. Okay, so another thing that you need to understand with this inheritance is program reusability, the code reusability. That is one of the most important um, advantage of inheritance. That is the whole concept of inheritance. Okay, and then most one of the most important features in object oriented programming. Okay, so what happens is when you create a new class, okay, you are reusing the properties of the existing class. Like in this case, okay, this is the derived class. This class is derived from this class. Okay, so when you are using this class derived when you are this class, it reuses the properties or the members of this base class. Okay, so what happens is that that is code reusability. Okay, code reusability. So uh, here in this particular program, okay, here in this particular program you see uh, the base class, the, that is named as base. Okay, then it has the data members. So this is the data members. It has only one data member, that is counter, and it is declared as private. So it is declared as private. So students, okay, go through the visibility modes access specifier very nicely. Okay, that you have to understand. Okay, so and then here, so when you declare this as private, okay, the derived class itself cannot access this. Okay, like it says, like in inheritance, right, the members of the derived class can access the members of the base class, right? Okay, or the derived class inherits the members or the properties of the base class, right? But in if the base class that are members or the member functions are declared as private, okay, the derived class cannot inherit that. Okay, in that case, okay, in that case what happens is that, or although the private members of the base class cannot be accessed directly, okay, yet objects of the derived class, in this case this is the object of the derived class, right? Okay, objects of the derived class, they are able to access the members of the private members of the base class through some non-private inherited members. Okay, through some non-private inherited members, that means public inherited member functions, like that. Okay, now so having said that about the private access specifiers, okay, so if it is private, okay, the derived class cannot access or inherit the private, cannot, or let's say cannot copy the private members. Okay, now in this case, as declared public, okay, you have here your member functions declaration and definition. In this case, this is your constructor. Okay, as you can see, the name of the function is same like the class name. So this is a constructor and this is the default constructor. Okay, so even here you will see that in inheritance constructor is used, right? So that's why I say constructor chapter, classes and object chapter, you have to go through nicely. Okay, so here this is your default constructor because no parameters are declared. So within this constructor body, the counter is initialized to 0. Okay, so by default, if by default what happens is that the default constructor always initializes the value to 0 or string values to null. Okay, so here the counter is initialized to 0, and then you have your normal member function. Okay, so the class base has its own member function which is called as void new set. Okay, new set in and within the parenthesis, and within this body function body, okay, the counter, okay, is equal to n. So whatever value that is being passed, okay, so here the return type is void because it only executes this statement counter equals to n. It does not return any value, right? This member function does not return any value. So this function, okay, declares this parameter of type integer. Okay, so declares this parameter n of type integer, and then the value that has been passed to this value variable n or parameter n, okay, is again transferred to the stored in the counter variable. Okay, now again you have here the return type void factorial void. Okay, so this is your factorial function declaration. Okay, so this is your function definition, normal function definition, and this is your function declaration, and this is your default constructor. Okay, so that much has been defined in using the class base. So this is your base class. Okay, so another class is created which has its own relationship with this class. Okay, so here the class name is derived, okay, and separated by colon, okay, public class, public base. Okay, now this colon, what is the use of this colon in classes and object and constructors and destructors? You use the scope resolution operator, right? Dot 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 dot, like that, two columns. Here you use one column. Okay, this column, okay, it indicates that the derived class, this class name, derived class name, okay, is obtained from the base class name. Okay, so it links this derived class with the base class, that this derived class, okay, that this class name derived is obtained from the uh, base class. Okay, so which means that uh, you are able to access the members, the derived class, the inherited class derived is able to access the members of the uh, base class. But that depends on the visibility mode, and in this case the visibility mode is public. Okay, so since it is public, so what happens is that it is able to access all the members of the base class. Okay, but except private. So the private data members or private member functions cannot be passed on, cannot be inherited by the derived class. Okay, and if it is public, okay, it will be passed on as public. Okay, that is provided the derived class needs it. Okay, the derived class, okay, if it uh, so suppose like inheriting the members of the base class, right? When you inherit the members of the base class, okay, you need not use it exactly as the code uh, is written. Okay, so modifications can also be done in the derived class. Okay, in the derived class on the code that is obtained from the base class. Okay, and use it as a new and use it on the new derived class. Okay, so you can make changes to the members that are inherited by the derived class. Okay, so if it is made public, okay, public members can be inherited as public. Okay, and if it is protected, okay, if it is protected, okay, then when it is when the derived class, okay, inherits that, it will remain as protected. Okay, in the case of private, if this is private, okay, then what will happen is that the public members, okay, the public members, when it is accessed by the derived class, okay, when it is inherited by the derived class, then if the access specifier is private, then even the public members of the base class will become private. Okay, then what will happen is that only the members of the derived class, the non private members of the derived class, can access that private base class members. The public members becomes changes to private members when this access visibility mode changes to private. Okay, in the case of protected, okay, if it is protected, then what will happen is that uh, the public members changes to protected. Okay, and then the protected members remains protected. In that case, okay, the member functions of that derived class can access the protected derived members. Okay, and then, okay, the subclasses can also access the protected members, provided it is protected. Okay, it has been declared as protected. So you will see that based on the visibility mode, private, public, protected, okay, it can be copied and transferred from one class to another class to another class, like that. Okay, if it is private, okay, it cannot be transferred at all. Okay, but if it is protected or public, okay, it can be shared among the classes from one base class to another derived class to another derived class to another derived class, like that. So that is the main advantage, the program code reusability. Okay, it may be that you do not want to write down the same code again and again, right? You may want to reuse that code. Okay, so that is made possible with inheritance. Okay, now in the case coming back to the program, okay, when you come to the main part, okay, here the variable has been declared as num, and then the derived class, okay, has declared an object, okay, t derived. So now what is the concept of constructor? When the object gets declared, what happens? The constructor is called, right? The constructor gets invoked. So this is the default constructor. So always remember that the here in this case, it is the derived class which is declaring an object, not the base class. Okay, the base class has not declared any object, but the derived class has declared an object. So this object belongs to the derived class. Okay, but what happens is that when this object gets declared, okay, always the base class will have a default constructor. That default constructor gets invoked, but it does not directly invoke this uh, constructor. It implicitly invokes it using the derived uh, inside the derived class body. Okay, so that's why here you can see that, okay, using the public access specifier, okay, this is the derived, this is your default constructor for the derived class. Okay, then this is the body of the default constructor for the derived class. Okay, here no statements are written because uh, okay, no data members are declared here, right? And then here using the colon again, you see that the base constructor, okay, so this is the base class constructor that is linked with the derived class constructor. So that means what happened is that, okay, when this object gets invoked, okay, since this default constructor is written inside this class definition, okay, so the the base constructor gets invoked. Okay, the class base construct default constructor gets invoked inside this derived class. Okay, this will be invoked and then it will initialize counter to 0. Okay, after that only control will come back to the derived class constructor, and then it will execute its statement, in this case the default value. Okay, so that way, okay, only, okay, the constructor gets called from the base class to a derived class. Okay, now again after that, if you see here, cout enter the value for factorial. I'm sure that you know all the concept of the factorial, right? So here in num. So what happens, suppose you enter the number for value for factorial is 6, so this 6 is stored in this num variable, right? So now using the object that is t derived, okay, and using dot operator, you are accessing the member functions, okay, the member functions of the derived class. So here if you see in the derived class, okay, in the derived class definition, okay, after the constructor gets invoked, okay, then here the this is its member functions, this class member function. Okay, for class space, this is the member function, okay, this one, okay, and for class derived, it has its own member functions. Okay, so it has this class derived class has its own member function, okay, but it can also make use of this uh, base class members, be it data members or member functions. In this case, the derived class has invoked the base class member functions, that is these two. Okay, so it is written here, okay, inside the body of these member functions. Okay, so it is the calling function, two calling functions are written here that calls these two functions, right? Okay, so when this gets invoked, it passes the value 6, okay, that is stored in this variable, and that value gets, since it is the calling function gets uh, invoked, right? So the calling function calls this function which has the same name, and that value 6 is passed and stored in this variable n. Okay, variable n. After that, within this function body, okay, the compiler comes back to the next statement and it sees the calling function. So this calling function new set n, it calls this base class member function. Why? Because it has been made public, right? The public base, so it can directly access the public members. So what happens is that the value which is stored in the variable n gets passed to here, and that is 6, right? And then that 6 is assigned to the counter variable. Okay, so that way you get transferred from the derived class to the base class, the value 6. Okay, then after that, next statement is factorial, so another calling function. Okay, so it invokes this function body. Okay, now keep in mind that this belongs to the base class, right? This function, member function, it belongs to the base class. So that using the scope resolution operator, that's why. Okay, and then the class, you can see that the class name is base, not derive. Okay, in the derived class, it does not have any data members. No data members are declared. Only one member function is has been defined, right? And the purpose of this member function is to call these two functions which belongs to the base class. So that's why when this factorial function gets invoked, okay, since this function belongs to the base class, that's why in the scope resolution operator, okay, section, we see that the keyword base is written, not derive. Okay, so now the formula gets executed. I'm sure that you have all know under what how this logic executes, right? Okay, if you do not know, okay, go back to class 11 and see the and do some try run methods. Okay, so that way what happens is that you are able to obtain the value that is 720, okay, which is 1 into 2 into 3 into 4 into 5 into 6, right? So that loop gets carried on in this for loop. Okay, so this is how you are able to use the concept of inheritance. Okay, and then okay, so study this program, try to understand this program. Okay, uh, okay, so that will be for today.